Hey class, today we're going to learn how to find percent composition. So we're going to learn how to find percent composition two different ways, and then we're going to learn how to use percent composition to find out our mass of certain elements within a compound. So let's get started. Introduction. The relative amounts of the elements in a compound are expressed as the percent composition, or you can also hear it be said as the percent by mass of each element. A good example is right here in this picture. You have the compound K2CrO4, which is potassium chromate. And here it's going to break down in a pie chart. Of that compound, 40.3% of that mass comes from potassium, 26.8% of the mass comes from chromium, and another 32.9% come from oxygen. Now, of course, since these are percents, they're going to equal up to 100. So that's another thing to keep in common, or like in your head. And the percent composition for a compound is always going to be the same. So when I say potassium chromate, it's always going to have this percent composition. If I find it for water, water is going to have a different than potassium chromate, but all water is going to be the same. So let's get into how to find it. So how do you calculate the percent composition of a compound? Like I said, there are two ways. The first way is the percent by mass of an element in a compound is the number of grams of the element divided by the mass in grams of the compound multiplied by 100. So if you're given the mass of an element and the mass of a compound, you can divide those two, multiply by 100, and that gives you the mass of an element. Let's actually take a closer look to that. So here is how you would solve percent composition if you were given the masses of the different parts in the compound. So let's actually see what I have. It says when a 13.6 gram sample of a compound. So I know that my compound is equal to 13.60 grams. I know that it contains magnesium and oxygen, so I need a magnesium and oxygen mass as well. And it says 5.40 grams of oxygen, so I know oxygen, 5.40 grams is obtained. What is the percent composition of each element in a compound? Well, there are two ways that you can solve this. You pick the way that's easiest for you. I'm going to show you both. One of the ways that you can do it is if the total compound weighs 13.6 and oxygen weighs 5.4, if you subtract those two amounts, you would hopefully get that magnesium is 8.2 grams. Okay. Then all you have to do is for each element, take its mass, so if 8.2 divided by the total, 13.60, times that by 100, and you're going to get 60.3%. You can do the same thing for oxygen. Oxygen equals 5.4 divided by 13.6 times 100, and you would get 39.7%. That is one way you can solve it. And you're going to notice that these percents add up to 100. Another way that you could have solved it is instead of finding magnesium's mass, you could have found the percent composition of magnesium and found that it was 39.7. And then knowing that they have to equal 100%, you could have taken 100 minus 39.7 and still have gotten this 60.3. So that's just one way that is different that you could have solved this same problem. So you go ahead and you try this problem and let's see how you do. Okay. Here it says if 14.56 grams of carbon, so I know that I have carbon, and it equals 14.56 grams, combines with hydrogen, so I know hydrogen is also part of that compound, 1.45 grams. What is the percent composition of the compound? Well, first I have to make sure I have all of my information. And the one thing that I'm missing is I need my compound's mass. Well, if these two things make it up, all you have to do is use addition. So 14.56 plus 1.45 gets you 16.01 grams. From there, you can do what we did in the last example. You can do for hydrogen is going to be 1.45 divided by 16.01 times 100. And for hydrogen, you're going to get 9.1%. And then for carbon, you would take carbon's mass divided by the compound's mass times 100 gets you 90.9%. Again, notice these add to 100%. Now, a second way that you could find percent composition is if you were given a chemical formula. So maybe you weren't necessarily given the mass, but you do know the formula. All you would do is find the molar mass of the element, using what we've done in previous lessons, find the total molar mass of the compound, and multiply it by 100. So again, instead of giving the masses, you're just finding them. Let's use this one as an example. Propane, the fuel commonly used in gas grills, is one of the compounds obtained from petroleum. Calculate the percent composition of each element in propane. So here I'm going to have carbon. I have 3 carbon, so I'm going to find the molar mass of 3 carbon, of all my carbon. And if you actually go to do that, it's 36.033 grams. For hydrogen, I have 8 of them. So if I'm going to find it for the element, I have to find all 8. And you're going to get the molar mass of 8.0632 grams. And then for the whole compound, C3H8, for the whole compound's molar mass, you've gotten 44.0962. Now, if you forgot how I did these, go back to that molar mass section and look how we calculated those. So then what you can do is, just like the previous example, take these masses and divide them. So if you were trying to find hydrogen, it's going to be 8.0632 divided by this 44.0962 times 100. And carbon is going to be the 36.033 divided by the 44.0962 times 100. So over here for carbon, you would get 81.7%, and then for hydrogen, 18.3%. So if I had propane, 18.3% of that mass is hydrogen, and 81.7% of that mass is carbon. So carbon does weigh a lot more, and we do know that. I want you to try to find the percent composition of water. Okay, let's get started. So again, if I'm given a formula, I just have to use my molar mass table. So if you found the molar mass of water, you would find that it equals 18.0148. And that's because H2, my element H2, has a molar mass of 2.0158, and my molar mass of oxygen is 15.999 grams. From here, all you do have to do is divide. So for hydrogen, you would take the total molar mass of all the hydrogen divided by the total mass of the compound times 100. And then for oxygen, you would take oxygen's molar mass, since there's only one, divided by the molar mass of the entire compound, times that by 100. And for these problems, hopefully you should have gotten for hydrogen 11.2%, and then down here 88.8%. So how did you guys do? And the last thing that we're going to learn about percent composition is using it to determine the mass of an element if you are given the mass of the compound. So the number one thing that you're going to do is calculate the percent yield of the element that you're trying to find. The only thing I'm going to say is you're going to calculate the percent composition and keep it in a decimal. So don't change it to a percent by multiplying by 100. Instead, you're going to multiply the percent composition by the mass of the entire compound. So let's work this out so you can see it firsthand. It says calculate the mass of carbon and the mass of hydrogen in 82.0 grams of propane. Now, we've solved for propane before. We know that for propane that we get the molar mass of 44.0962. We know that hydrogen was 8.0632, and we know that carbon was found to be 36.033 grams. Here you're going to solve just like all the other ones. Even though I've already solved it, I'm going to re-show you how to solve it. We're going to find the percent composition, just like we did before. So for hydrogen, it's going to be 8.0632 divided by 44.0962. For carbon, it's going to be that 36.033 divided by the 44.0962. Now here's where I said you have to leave it in a decimal. We're not going to multiply by 100 like we have in previous examples. Instead, we're going to take this 82 and we're going to multiply by 82 times 82 grams. And we're going to solve that way. So if we actually solved that way, you would actually find that carbon would be 66.994 grams. And if I take my calculator and I solve for hydrogen, so I take that 8.0632 divided by that 44.0962 times it by 82, I'm going to get 14.994. And if you actually add these 2 grams together, you get 81.988, which actually rounds up to 82 grams. So both of those added together equal that 82 grams. Okay. So what I want you to do is I want you to actually try to do this example by yourself, and let's see how you do. So in this example, it says, what is the mass of oxygen in 20.2 grams of H2SO3? So furic acid. And instead of finding all the elements, it's just asking you to find oxygen. So let's get going. If I were to find the molar mass of H2SO3, you would get the molar mass of 82.0778 grams. Since I'm only asked to find oxygen, I just have to find O3 is 47.997 grams. So for oxygen, you would take that 47.997 grams divided by your 82.0778. Again, instead of multiplying by 100, you're going to multiply by the 20.2 that it gives you up here. And you're going to find out that 11.8 grams of this sample is made up of oxygen. So 11.8. So how did you do? That's the end of the lesson. If you do have any questions, please let me know and I will help you. Tomorrow is actually going to be a work day, so then you can catch up on any of the homework you've maybe had trouble on, ask me questions, and I hope you have a good day.